In this video, we'll be looking at the central limit theorem for sample proportions. The central limit theorem tells us what to expect if we collect data from multiple different random samples. In a previous unit, we learned about the normal model and how data can be normally distributed. Good news! The normal curve is useful in other circumstances. Let's say we are interested in finding out the proportion of people who are pet owners. If we draw a random sample, we might get one answer, let's say 37% or 0.37. If we draw another sample, perhaps 35% of those surveyed are pet owners. If we do it again, we might get 40% or 41%. Our proportions will vary as different sets of people would be surveyed in each case. The good news is that if certain conditions are met, our proportions will be normally distributed. First, check for the randomization condition. This means that all samples must be randomized. Then, check for the 10% condition. This means that the sample size cannot be larger than 10% of the population. Finally, check the success-fail condition. Your sample must be big enough to have at least 10 successes and 10 failures. I'll go into more depth with how to check these conditions in another video, but for now, just remember, to use the normal model, the sample size cannot be too large and cannot be too small. It must be just right. If all three conditions are met, when we create a histogram with our proportions, they will be normally distributed, and our actual population proportion will be at the center. Before we jump into an example, let's make sure we remember what the normal model looks like. In our normal model for proportions, the actual proportion will be at the center, and most of our possible proportions will lie within 3 standard deviations below this proportion and 3 standard deviations above this proportion. More specifically, 68% of proportions lie between 1 standard deviation below and 1 standard deviation above the actual proportion. 95% of proportions lie between 2 standard deviations below and 2 standard deviations above the actual proportion. And 99.7% of the proportions lie between 3 standard deviations below and 3 standard deviations above the actual proportion. In these problems, we won't be given a standard deviation, but not to worry, we can calculate it. The standard deviation will be equal to the square root of p times 1 minus p over n, where p is the average or actual proportion and n is the sample size. Everything will become clearer as we work through an example, so let's begin. The World Pet Association states that 37% of people are pet owners. A town randomly collects a sample of 200 people and 90 of them are pet owners. Is this an unusual proportion? Assuming all conditions are met, we can use the normal model. Our average proportion is provided, 37% or 0.37. We calculate the standard deviation using the formula. Standard deviation equals the square root of p, which is 0.37 times 1 minus 0.37 over the sample size, 200. This gives us 0.0341. Now, we add 0.0341 to 0.37 to get 0.4041. We add the standard deviation again to get 0.4382, and once more to get 0.4723. We take 0.0341 from 0.37 to get 0.3359. We take the standard deviation away again to get 0.3018, and once more to get 0.2677. Recall that in our town, there are 200 people and 90 of them have pets. In the town, 90 out of 200 people have pets. When we divide 90 by 200, we get 0.45. On our curve, 0.45 lies in this area. 0.45 lies within 3 standard deviations from the mean, so it isn't entirely unusual. However, this proportion position on the normal curve does show that the proportion of pets is higher than it would be for most other samples. Let's look at an example that will allow us to get more specific. What is the probability that another randomly selected sample has fewer pet owners than the sample from our previously discussed town? 50% of proportions are on the left side of our line of symmetry. From the line of symmetry to 2 standard deviations above the average proportion, we divide 95 by 2 and see that there is another 47.5% of proportions. And here's a bit more. 50% plus 47.5% plus a bit more tells us that more than 97.5% of samples selected will have a smaller portion of pet owners. To get the exact probability, we can use a z-score table or a statistics calculator. Here's a summary of what we've learned. The normal model can be used to represent the distribution of proportions for several samples. Required conditions are the randomization condition, the 10% condition, and the success-failure condition. The actual proportion falls in the center of the normal model. The standard deviation of the proportion can be found using the formula standard deviation equals the square root of p times 1 minus p over the sample size.